For centuries, China's destiny has been intertwined with its mighty rivers. But these life-giving giants can also unleash ferocious fury. Floods have ravaged the land, testing the resilience of its people. In its pursuit to manage the risks, China has embarked on a multifaceted journey to mitigate flood risks, protect livelihoods, and safeguard its burgeoning cities, which you will learn more in the video. As new challenges emerge, rapid urbanization shrinks floodplains, leaving communities more vulnerable. And the question remains, can China tame its rivers once again? Join us on a journey to discover how China is adapting its fight against floods. Witness the evolution from traditional muscle to a sophisticated blend of infrastructure, nature, and community engagement. China has a rich history of managing floods, dating back centuries. However, rapid urbanization and increasingly severe floods have presented a dual challenge, causing economic setbacks and loss of life. What is China's history with flood management practices, and what are its plans for the future? China's civilization has always been closely tied to its rivers, which served as the lifeline of communities. Ancient societies developed innovative techniques like dikes, canals, and levees to control river flow and protect settlements. Notable achievements include the Great Jinjiang Levee, a testament to early flood control along the Yangtze River, crucial for safeguarding communities and fertile lands. Traditionally, China relied on structural measures such as dams, reservoirs, and levees for flood control. However, as populations grew, flood damage persisted despite significant investments. While large-scale reservoirs were built in the mid-20th century, their aging infrastructure and design flaws present challenges today. City planners face difficulties in providing adequate infrastructure, leading to settlements in flood-prone areas and outdated drainage systems. Inappropriate land use management exacerbated flood vulnerability, with cities encroaching into lower protected farmland. Large-scale reservoirs were built in the 1950s and 1960s, but their design and construction standards were less rigorous than today's aging infrastructure, and hidden defects pose challenges. Recognizing that structural measures alone were insufficient, China shifted toward a more integrated flood management approach. This approach adapts to changing social, hydrological, and environmental conditions along major waterways. The Ministry of Water Resources prepared a national flood management strategy, emphasizing the need to live with flood risks rather than solely relying on structural solutions. Of all of the structural advancements and changes that China made to its architecture in the past, none were more efficient than the sponge cities. Floods can cause huge losses of life and property, disrupt transportation and communication, and damage the environment. To cope with this challenge, China has adopted various measures to prevent and mitigate the impacts of floods, such as building dams and levees, improving weather forecasting and early warning systems, and enhancing emergency response and relief capabilities. However, these conventional approaches have also brought some negative consequences, such as ecological degradation, social displacement, and increased vulnerability to extreme events. In recent years, China has been exploring a new paradigm of flood management based on the concept of sponge cities. Sponge cities are urban areas that can absorb, store, and reuse rainwater rather than draining it away quickly. Sponge cities aim to mimic the natural hydrological cycle by increasing the permeability of the urban surface, restoring the ecological functions of wetlands and green spaces, and creating multifunctional infrastructure that can reduce flood risks and enhance urban livability. Sponge cities can also help address other urban challenges, such as water scarcity, air pollution, climate change, and biodiversity loss. China launched the Sponge City program in 2015, with the goal of transforming 80% of its urban areas into sponge cities by 2030. The program involves 30 pilot cities, which receive financial and technical support from the central government. Some of the key features of sponge cities include permeable pavements, which allow rainwater to infiltrate into the soil and recharge the groundwater. Then the rain gardens, bioswales, and green roofs, which capture and filter rainwater and provide habitats for plants and animals. Also, the rainwater harvesting and reuse systems, which collect and store rainwater for domestic, agricultural, or industrial purposes. Detention and retention ponds, which temporarily store excess rainwater and release it slowly or use it for irrigation or recreation. Natural and artificial wetlands, which regulate the water flow, purify the water quality, and enhance the ecosystem services. Sponge cities have shown promising results in reducing urban flooding, improving water security, and creating more livable and resilient cities. For example, in the city of Xiamen, the Sponge City project has reduced the runoff coefficient, the ratio of runoff to rainfall, from 0.6 to 0.3, increased the water supply by 233 million cubic meters per year, and created 2.4 million square meters of green space. In the city of Zhengzhou, which suffered a devastating flood in 2021, the Sponge City project has reduced the flood peak by 36%, decreased the flood area by 41%, and saved 1.3 billion yuan or $200 million in economic losses. In Wuhan and other participating areas, they must ensure that 20% of their urban land includes sponge features by 2020, with a target of being able to retain 70% of stormwater. For Wuhan, that equates to just over 170 square kilometers of a total urban area of 860 square kilometers. And last year, the sponge projects were rolled out to a further 9 districts. The nationwide program has been expanded to cover 30 cities. By 2030, participants must ensure that 80% of their urban land includes sponge features. Contrary to traditional stormwater management systems, which are generally buried underground, sponge city systems are mostly built above ground and scattered in large regions, some located in private land interfering with public life. Therefore, public opinion and acceptance of sponge city construction can easily hinder its success. Considering the importance of public acceptance, the education efforts in China are deficient both in quality and in scale. More educational efforts are needed for a broad array of groups, including political leaders, administrators, agency staff, planning and design professionals, developers, builders, landscapers, and the public. To achieve public outreach goals and shift public perceptions, a complete education program involving the technical training of municipal staff and lessons in sponge city concepts for the public are in demand. These lessons must be incorporated into formal and informal education programs for institutions and communities to fully understand the sponge city concepts. As a new approach for urban water cycle management, the success of China's sponge city construction relies on the identification of challenges and adaptation of effective improvements. To achieve a bright future, the following critical improvement opportunities are identified. Sponge city construction aims at resolving various problems associated with urbanization at multiple scales, and ultimately at establishing greener and more holistic urban environments. Some earlier efforts defined the sponge city as runoff volume-focused LID measures, and set up volume control criteria as the sole control parameter. It narrowed the sponge city concept. Thus, some pilot cities focused on discretized LID measures at the source level and lessened the importance of connectivity at multiple scales. Taking an integrated watershed scale approach and focusing on the connectivity of the source community region watershed scales can prevent the segmentation and isolation of the system and focus on the full benefits of sponge city approach, such as natural conservation, flood reduction, ecoservice enhancement, and water resource protection, and ultimately promote a healthier watershed. The success of the sponge city approach relies on the understanding of local issues, conditions, and potentials. It is essential to carefully assess specific problems in the city and resolve these by leveraging the local potential and regional resources. Currently, the lack of guidance and design standards from national, provincial, and local levels make the following elements of sponge city projects difficult: assessment, planning, design, construction, operation, maintenance, and monitoring evaluation. To ensure the success of sponge city construction, it is urgent that national and provincial guidelines be completed to help local governments develop local sponge city construction manuals design standards. These documents should be based on a careful assessment of local conditions and potentials with input from local developers, planners, and engineers. Various education programs should also be established to provide training to government officials, public works employees, planning and design professionals, and the public. In addition, there is a strong demand for performance, costs, and life cycle data from pilot demonstration projects practices in various natural conditions. In China, drainage systems typically handle up to a 1 in 10-year storm. But with the introduction of sponge city projects, cities like Wuhan aim to upgrade to handling a 1 in 30-year storm. Since the launch of sponge city initiatives in 2015, major challenges have emerged. High costs and maintenance demands, potentially burdening local governments and communities. Also, the lack of coordination among sectors and stakeholders, leading to conflicts and inefficiencies. This also leads to uncertainty in the effectiveness of sponge city measures, influenced by local conditions. And the risks such as groundwater contamination, diseases, and social inequality began rising. To ensure the success of sponge cities, China must adopt a comprehensive, adaptable approach involving various actors like government agencies, private sectors, and academia. Learning from global best practices, particularly in Europe, Australia, and Singapore, can enhance China's flood management efforts, turning challenges into opportunities for a balanced coexistence with water.